Okay, guys, here we are back at my quad, and one of the things that occurred to me while this was charging was, if you look carefully, you'll notice I've got a couple different setups here. One's Belkin. It's both its discharging amps. Both its discharging USB ports are 2.4 amps. This one is 2.4 amps on the top, 2.1 on the bottom. I noticed that even on the 2.4 setting, this one doesn't kick as hard as this one. This one charges my phone faster than anything else I have, which means it is the strongest charge. So I wanted to talk to you guys for a quick second about that and about how that is impacting our performance with a helicopter or anything like that. Now, I noticed a long time ago that if I were to take a battery and charge it with a weak charger, you get a weak charge. If you charge it with a stronger charger, you get a better charge. Not necessarily. A charger is a charger. As long as it's supplying the right voltage and amperage, it's great. So that's what you really need to look at. Now, I've got a 3.7, 350 milliamp battery that I want to slowly ramp up to 1,000 plus. One of the ways I can do that is by selecting carefully how I charge. The first 4 full charges on this battery, including the one I just finished using, I did on this one on the 2.4 amp setup. Now, it won't actually give 2.4 amps, but it'll allow the helicopter to draw a stronger charge than it was originally designed for, if it so desires. And with this little guy, it'll give it 1200 mAh. It'll charge faster and stronger through one of these than it will through this. But this will charge stronger and faster than the regular ones that are 2.1 amp. So, I have experimented, and this one are definitely different. This one and this one are definitely different. Even though these are both identically rated for 2.4, these are definitely stronger. My guess is this one's more like 2.2 or 2.3, and its other port is probably 2.0. That's common with these. That being said, we are charging the heli now, and we're charging it from this stronger source. Now, I had noticed at first when I tried to charge this battery with this charger, with this block, it started to really heat up. Now, I just plugged it in a little while ago, but I'm not noticing any heat build up in here now because it's not being fed back from the battery, because the battery has successfully been programmed to accept a higher charge, which means it's getting right in the neighborhood of that 11 or 1200 mAh that I actually want it to run at. Now, don't forget, I've also included an aluminum heatsink on the battery itself so that it won't have a weight problem. No, so that I can make sure that I cool this battery during the process of its breaking in. Too much heat will damage it chemically, and it won't be as strong afterward. The last video I was flying most of the time and got 10 minutes. I'm not even sure if I'll upload it, but I got 10 minutes flight time. See, I tend to record absolutely everything. And one of the reasons I do is because a lot of that turns out to be useful for me to see later, and I can watch the behavior of the helicopter or the boat or whatever it is I'm working on and see the details. In a case like this, I have been doing so much of this kind of stuff over so many years, I've learned a lot about it. Perfect example, if you're going to run an RC drone or helicopter off of a rechargeable battery station, the stronger the batteries are, the better the charge you get. Well, this is no different. The stronger the source, the better the charge will be, and the better that battery will be. But had I pushed it early on to take this kind of power, I would have probably damaged the battery or cooked it. Now, you can see here I've got a pretty substantial aluminum heatsink casing on this. It's quite large. It's about 1.5 inches long, which gives it a ton of surface area in the air, which is really great for cooling. I have to plan out all those things if I don't want to fry anything. So I not only planned on what I was going to do to upgrade the battery, but the heli as a whole, individually. So on the battery side, I wanted to have an increase of mAh of at least double. I have absolutely achieved that on the first charge. I know that a couple of ways. One, I know this guy's charge times from having had this helicopter for quite a while, drone, and its charge times ranged right around 45 minutes, half an hour. depending on how badly I had drained it. And I've noticed that it was right around the same with this battery. It's been giving me right around the same consistent charge time, which means it's charging it to the same level. They're both 3.7. If they're charging to the same milliamp, they'll have about the same charge time. That being said, that must be the case. So I am getting good amperage out of it, good milliamp hours. But right now I'm suspecting it's only between 900 and 1,000. This will help bump it up to the proper amount that it should be. And I'll keep checking, but so far, this is no warmer than it normally would be during a charge. And that's a really good sign, because it means, okay, if there's too much power flowing to the battery and the battery can't accept it, this will heat up unusually. It'll heat up more than usual. And the reason is you'll have a current going up and then coming back because it can't get into the battery. It'll actually backfeed into this. That's bad. It won't kill anything. It'll just overheat it. And that could fry it. So, yeah, it could fry it. Also, you don't want heat building up because it's going to travel through the wires and go into the battery, believe it or not. So any heat buildup you feel here is going to transfer to the other end before that battery is fully charged. One of the good things about having the aluminum heatsink on it is that I can cool it at that end. Should something like that happen, it'll be cooling the battery, and I'm unlikely to lose the battery. I'm more likely to just damage the charger. That being said, one of the ways you can avoid things like that happening is to slowly ramp them up. Get yourself a cheap dollar store power supply, then get yourself a middle-of-the-road one that's running 2.1 to 2.4 amps, so it says, and then get yourself a really high-end one and step it up. Start with the cheap one. When you have, say, a 350 mAh battery, you want to upgrade it. You don't want to have a bigger battery. You want to have the same weight. You just want more power out of it. That's what I'm doing here, ramping it from a 350 milliamp hour battery to a 1,000 plus milliamp hour battery. Now, the only way I could prove that out would be to test it. I have an electrical tester, ladies and gentlemen, but I am not going to apply that until this process is complete, and I believe that I've gotten as much power as is physically possible out of the battery. Once that happens, and I'm sure that I've got it programmed for its maximum power, sorry about that, I will shoot another vid, and you guys can see that, and I will show you on the tester exactly how many milliamps it's reading, and it'll go by amp. So if it's 0.1 of an amp, it's 100 milliamp. If it's the same 350 milliamp it was started out as, it'll say 0.35 of an amp. If it's giving us what I want, it should be 1 amp or more. I'm experimenting somewhere in the area of 1.0 to 1.01 or 1.12, somewhere in that range. I don't think I'll get any more than 1.12. However, that'd be 1,120 milliamp hours. That would be a lot more. Now, this is what I recommend. Just keep checking it every few minutes. That being said, it's still doing fine, no increase in temperature, which means guaranteed the battery is taking charge. And that is not the same as it was the first time I plugged it into this. Now, it is taking a stronger charge with less resistance to the battery. The battery is actually accepting that charge now. It did not the first time I plugged it in. I had to train it first on this slightly weaker one and bring it up a bit. Now I'm stepping it up. When I'm done, this will be stronger than ever. Tomorrow's flight will be outside. Keith out.